So in morning session, we discussed about our Center for Advanced Study program, and we went over our cloud platform and how to use it. Now in this part of the workshop, we will discuss our data and AI services, followed by a demo. And then we will start a discussion where you suggest a project idea or any potential idea you have, and we can discuss briefly what can be done in that space, and we'll follow up afterwards. So hope now all of you can see my data and AI services slide. Okay, so should we start or wait for some few more minutes?
I think we could get started.
Okay. So we already showed you this slide of all the services, 300 plus services we have on our catalog. Let's go a little deeper on the AI services, what we offer. So I put along with the AI some of our analytics and database services, because a lot of time AI involves with a lot of data handling. So for the AI services, as we were talking about, there are three major points. One would be off-the-shelf services like our NLP, NLU services, speech-to-text, text-to-speech, discovery, and so on. That's something you can use directly in your research if you see fit. Then there is another portion, which is Cloud Pack for Data. Basically, it combines all our services and gives you freedom to run it anywhere you like, whether you want to run all our feature portfolio in your on-prem cloud or in someone else's cloud. You can do that through IBM Cloud Pack for Data. And then another third piece, which our demo would be based on later this session, that is data science platform. We have a very nice and intuitive data science platform, which kind of connects various data governance tools, different data repositories, interfaces to different type of database, so let you manage your data assets, as well as it provides a lot of tools and services to analyze your data set. For analytics, like if you have a streaming analytics or like you Spark, Hadoop, or Kafka, all are available to our analytics portfolio. And in database, you can get a different type of data, SQL databases like SQL, NoSQL, Graph, and other database solution, including our Hyperledger Fabric blockchain. So let's go one level more detail in the AI portfolio. So what we will do in AI portfolio, I would introduce those three major components, and towards the end, data science platform, which would be our segue into the demo. So let's see some of the self-services. I'm not going to mention all, but let me highlight two of them. So one is our Watson Discovery service. It's NLP and NLU based services. It gives you a power of text analytics. So think of it as a service where you provided a lot of data, a lot of textual data, for example, research papers, books, articles, news, and then you can get insight out of those data. And now we are talking about millions of such data points, be it the social media feed or product reviews or research papers or news items. And people have given that those different kind of data set to discovery tool to kind of organize that data set into the graph data set and extract insight from it. So people have used it for market analysis from the market news, or very recently you put all the COVID research paper and it helps you to kind of find the relation, how people are exploring in the academia about different proteins. So the use cases can be anything which involves huge amount of text data. The process is something like this. You collect all these data, give Watson Discovery to ingest it. While ingesting it, provides you a lot of tools. For example, you can take a research paper and highlight different portion of it, title, abstract, a particular text you are interested in, and later on you can query with those filter criteria. So it gives you a lot of ingesting data ingestion tools. Provides you interface to enrich your data. You can off-the-shelf train a machine learning model for entity enrichment in a natural language text and put it inside the discovery as an additional intelligence. So it has its own enrichment, but it also offers you interface to add your enrichment to it. And then next you can continuously test the insight discovery is giving from your data. And if you see, you can, because it's a machine learning based engine, so you can always train it to get it improved. So we are seeing a lot of use cases of this particular service in our academic collaboration. And some are using it for drug discovery, as I said. Another group was doing the one group was doing the COVID-related research, and another was with the antimicrobial resistant-related research. They got all those research paper and clinical study, put it into discovery engine, and later on building something on top of it. We saw many people coming up with the expert system idea. So as opposed to having a Google search, which is a generic search engine, you have your own data and you want an AI-based search engine to run on top of it and offer its user insight from the data set you have generated. So we found useful from different libraries, different support groups for different type of diseases. So people were building these expert system using this particular service. We also found some of our colleague in finance domain, business and finance and economics. They were taking the news article publication regarding different companies and coming a new investment strategy. So there are various options for this type of service, and this is one of the services we have in our portfolio. In the back end, it's trained with 3,000 plus machines. There's big natural language model which are getting utilized in this particular service. But as a user, you can then focus on more on the value you want to get into a particular research field. So another one which is quite popular among students, I would say, would be creating chatbots. And we have a very rich interface for creating a very complex chatbot, which could be multi-dialogue, could be branching, looping in the conversation. And just a trivia side note, we have 2 or 3 years back, we already demonstrated our capability of conversation when we demonstrated Project Debater, where it can debate to someone. So all those deep research has gone into building this chatbot service we enable users to use, where on any domain.
But she's only eating the tip of it though, so it could.
So a user can develop any type of chatbot for various domain. And over the time, we have seen different professor wanted to have a chatbot to answer their Piaget post or kind of use as their teaching assistant. So we saw many teaching assistant chatbot getting built in different universities. In some medical use cases, we saw people have a very specific dialogue set, and they wanted to automate that through the Watson assistant. So we saw that, and someone wanted to just have a Iron Man inspired Jarvis-like interface for doing their other tasks. So those type of use cases we are seeing in senior design, in other type of projects coming along in the academia for this particular service. So along with that, NLU service to kind of a lot of time people use it for means getting insight from the product reviews to make a marketing application. We have seen services text to speech, speech to text in kind of robotics and IoT. So a lot of these off-the-shelf services can be used in various projects if you see it fit. Now, just switching the gear to a different type of services as opposed to off-the-shelf services is Cloud Pak for data. So this is in itself, it's a platform. What it gives, as opposed to combining and interfacing multiple services, you can get all those services integrated as a drop-down menu that I want a discovery, Watson, a particular type of SQL database, a NoSQL database, a type of compute environment, and a type of notebook, and so on. So all those tools you can select as a drop-down menu and pack it into a particular what we call Cloud Pak. And then you ask it to run anywhere you like, whether on IBM Cloud or your on-prem, or let's say AWS Cloud. And it's built on top of OpenShift and all these services as a part of containers, including all the softwares you need. So this offers a true hybrid cloud experience for doing your data and AI workload. And the tools in this particular Cloud Pak for data starts from data collection tool, data organization tools, data analysis tool, and then some sort of business process improvement or business insight tools into it. What we are seeing for cost-effective reasons, and sometimes there are restrictions where certain data cannot move from on-prem, but there are types of data which can move from on-prem. So a lot of those data governance issues can be resolved by having something, a truly hybrid cloud platform for all your data and AI need, and Cloud Pak for data is one such solution. So within the Cloud Pak for data, as it has various components, lot of tools for data collection, lot of tools for organization, but let's focus for remaining time on its analysis tool within the Cloud Pak for data. So some of the analysis tool would help you to in the data preparation. For example, for any machine learning project, if you are you just want to see if you have a quality data or not, you rely on some tools to do that. So there are a lot of tools integration to check your data quality. And if at all you have to perform some sort of like data imputation, data refining, and so on, that you can do with those data preparation tools. And then comes a tool set to build and train models, right from a visual tool to notebook-based tool to auto AI tool. There are tons of tools there in this platform to help you to build AI models. And when you train, you require a lot of framework libraries. So many open source supported frameworks are already included into it. It also provides you interface to bring a container or bring a file for the type of interface you are interested into, and not part of already a huge portfolio of open source software. And then once you have trained your system, you want to do the model management, for example, retrain the model, see the deploy the model, see the performance of model over time. That you can do. And there are another set of tools which also kind of monitor your model for transparency, bias, trust, and the drift over time. So in a nutshell, this analyze part is very much of interest to many of the universities, because direct application to their data science curriculum or data science based project. So out of all those tools, let me pick two of the tool to go in more detail. One tool is Watson Studio. So what Watson Studio does, it's kind of, think it as a front end for the data science interface. You can use all the tools offered by it, for example, Jupyter Notebook, RStudio, AutoAI, Data Refinery. It also have a lot of inbuilt supported framework for machine learning and deep learning runtimes, and then a way to link all these training to a different type of platform, whether you want a Hadoop Spark based notebook or containers to do the training, or you want a distributed deep learning training, you want GPU based, non-GPU, x86, name it in terms of hardware. Those are integrated with this platform. So as a user, you don't need to worry about wiring those. And then for a backend, for a machine learning job, it kind of relies on another service, Watson Machine Learning, which is depending upon what environment you want. Let's say you want to run a PyTorch, it kind of creates an environment for PyTorch and manages it for you. For example, does the training, gets the output, gives you API to interact with your training going on, and you can deploy your model, keeps the versioning of the model, and so on. So that's being done by Watson Machine Learning as a backend, doing the model management, and the front end is connecting all the tools from analysis to machine learning to the hardware, different databases, and so on. And as I said earlier, all these tools can be run locally on desktop, can be run on on-prem servers in the university, or can be used directly through our cloud credit program on IBM Cloud. So, as I said, this Watson Studio portion helps you to connect to like a lot of time to any data source. So, for example, a lot of time faculty comes and say, okay, I have this data set stored into my university data storage, but it follows an NFS or SMB type of interface to access it. Someone says like my data set is in Amazon S3. So people have kept data. Someone says like, okay, we have a NoSQL database, our own custom database. So then the point comes how to integrate your platform to those type of data set stored anywhere. So this particular platform offers you connectors for any data any data storage type, and that's a big list you can see, and it covers most of the commonly used data sources, right from Google Drive to AWS S3 to cloud object storage within IBM Cloud, or any type of storage within cloud, or any NFS or SQL or NoSQL interfaces. So then once you have connected your data set to the platform, now the next is what are the tools you can use to analyze it. So again, you can use lot of time data preparation tool and data analysis tool. So it offers you a lot of data analysis tool and data preparation tool. Some of them are visual because some places people want a visual tool. Some of programmable tools like Jupyter R would be given. Along with that, it has a lot of visualization tools. So at the same time, you are preparing the data or you are analyzing the end results, you can visualize them. So this platform offers a drag drop option. And in a minute, James would show that in a demo for selecting all those tool assets into the platform for your project. And once you have done the using that, you build the model, let's say. And now the next task is to deploy the model and kind of monitor it over time, how the model is performing, logging all the interaction happening with the model. So those type of interfaces are also provided in this platform. So in a nutshell, this is quite popular among people who just need a Jupyter notebook to people who need to teach data and AI pipeline, the end-to-end data and AI pipeline. So the backend component of this service is our machine learning service, which offers API-based interaction. So a lot of time I interact with these students and they say, I'm used to running machine learning models on my own laptop. But then you are limited by the framework you install on your laptop, the hardware you install, the versioning you do for different model. All that can be given to machine learning, Watson machine learning, which would take your model definition, your infrastructure definition, and run, create that kind of container which has all those runtime and required hardware, and run your training. And as a user, gives you API interface to interact with whatever training is going on. So kind of doing the same thing, but at very large scale and with a varied environment. And that in complete model lifecycle is a lot of time really useful in many research projects where you try a number of things to experiment with. Another thing, IBM is really big on trusted AI. So ethics component, bias, transparency, and how AI is performing over time, and explainability of a particular AI. Because these days you will hear a lot of regulatory requirement where someone is saying, you cannot just hide behind that, I'm not doing it, I'm not making the decision, my AI system is making the decision. You have to better explain that AI system, why it comes to a particular decision. So trust or explainability as a whole is a very big area of research, and right now very popular. We have some of the self tool as well as open source tool to help in this regard for different type of compliances, doing bias, explainability, and checking the transparency of an AI decision. You should be able to explain it. So it's linked with our machine learning engine. So if someone wants to explain what is happening, they can do with set of tools like OpenScale within Watson Studio. Another thing we find very useful within Watson Studio is to use a type of tool, Auto AI, and it can be used in various ways. One way of looking at, give it a data, see what Auto AI is, how Auto AI is. So Auto AI is nothing but end-to-end data and AI pipeline. So you give it a data, you say like, that's the outcome I'm interested into. What Auto AI would do is to take your data, split the data into training, test set, do the data cleaning and data preparation work. Once those done, it would see, given a particular outcome interested, what kind of algorithm would be the best pick. Tons of out of many algorithm, it would pick the algorithm to run against that data set. Do the feature engineering, hyperparameter optimization, and do that many times to come up with a particular algorithm and with particular type of optimization, come up with many model candidates. You can compare their accuracy against certain metrics, and you can deploy them, the end result of the model. So in a nutshell, it does the one complete AI job from end to end. And a lot of time, it's a good learning exercise for the students just to see everything happening from one end to end and then go why auto AI did make those decisions. So at each decision point, like model selection, data preparation, hyperparameter optimization, we have the research papers within IBM Research, what has been used to decide a particular model or particular parameter optimization. That could be a good learning for the students to just see how auto AI makes a decision and then how they are making a decision in more customized manner in their project. So it is very good in that sense for the classroom work, but at the same time, we are seeing many collaborators who are using it for different research purposes too. So these are some of the tool set into that Cloud Pak for Data platform, and I focused on the Watson Studio part of it, which had front-end engines to connect to different data analysis tools, and then the machine learning in a backend for model management, and giving you another analysis tool example like Auto AI, because we will show you demo of this and then we will come back and discuss more about the data science platform. So in a nutshell, how Auto AI is working, as I said, it makes a lot of decision. It makes a decision on what kind of data preparation work has to be done on a given data set. So once you bring your data set, it will do that. And to do that, we have a lot of research paper. We use concept from that and developed from IBM Research. So you can read through those papers and see what IBM has used to kind of clean and prepare your data. Then similarly, pick a particular algorithm for either regression or a classification problem and so on. And then what kind of parameter optimization it's doing, what kind of feature engineering it's doing. And after that, actually coming up and building the model for you and deploying that. So that is something we would like to show you as a demo, just to connect all these services we are talking about, right from Watson Studio to machine learning, to different database, to this Auto AI tool in a demo so that it all combines really well. But this is one set of services within IBM Cloud Data and AI portfolio. And we need a workshop to even go over half or few more AI services, but I think this would give you a good points for discussion coming in the project learning. So over to you, James.
Yeah, thanks, Anand. Yeah, like you said, we're going to be highlighting Auto AI portion of this service. But before we jump into the actual demo, I just wanted to sort of map out where the services connect. So Anand sort of gave details on this, but we'll have the user will normally interact with Watson Studio. That's sort of the interface. It connects everything to glue. But Watson Studio uses Watson Machine Learning for the compute. And then both Watson Studio and Watson Machine Learning to store the data sets, to store the models and the notebooks, they'll be using Cloud Object Storage. So I've gone ahead and already set that up in our demo to save that time. Of course, like Anand said, we could have a whole workshop on how to do all the details for configuring things, which I'm happy to do as a follow-up for anyone who's interested, but we'll cut some of that out of this, this demo. So actually so this is the screen of Watson Studio. This is the interface. I just want to actually page back to the screen you've seen before, which is the resources in the account. So this is the same IBM Cloud Workshop demo account. And in these three services here, the machine learning, the Watson Studio, and the Cloud Object Storage, these are what have been provisioned and connected to bring us this interface, which is the actual Watson Studio part of the Cloud Pak for Data. So it's just different view, but this is actually the service we're going to interact with. So yeah, so we're going to show off a Auto AI demo. There's a few things I might just point out about Watson Studio in general, but here we're in the assets page. So this is where you could add your own data sets to a project, or you could add Jupyter notebooks, or in our case, we're going to add Auto AI experiments. So before I click this, I want to showcase where you can access data. So you're always able to add your own data to this, and you can add connected data or connection to a data source like a database. You can also upload data from your local computer. But I just want to show that there's another way you can access some community data that IBM has curated. So under this navigation menu, we have the gallery. And so this gallery is kind of interesting. It has not only curated data sets, but it also has sample Jupyter notebooks and even sample projects. And the term project for us refers to a sort of like a workspace within Watson Studio. So there's a lot of things that could be explored as like a getting started. For our Auto AI experiment that I'm going to showcase, we're going to use data from the gallery. This is titled German Credit Risk Dataset. So this is what this dataset contains is a list of almost like loan application anonymized with some information about like the amount of the loan requested, how long they'll want to have the loan, their zip code of the person applying for the loan, if they have other loans. And then that sort of data will be used to determine whether or not this is a risky loan to provide. So this data set might be used in the bank's perspective. So I've actually already associated to the project we're working in, but you can click add to project from the gallery and associate with Watson Studio project, which is kind of convenient. So it should already be there. So I'm going to page back to our Watson Studio project. So I have an existing Auto AI experiment, but I'm going to create a new one from scratch. And you can see the data is right here as well. So scroll back up. We're going to add an Auto AI project. Give it a name, Credit Risk 2. You'll see that it actually is associated with a Watson machine learning instance. So this is the connections that we mentioned at the start. It's using some environment here to actually do the training, which consumes some amount of capacity unit hours, which is how they measure the usage for Watson machine learning. So we'll just go ahead and create this. It'll ask us in the next step what data to use, which is where we'll use this credit risk or credit loan data. So yeah, so we can select data from our computer or we can select it from the project. So I'm going to grab the data asset we have. It tells you some info about it, and then go ahead and select that. Okay, and then Auto AI. So the one nice features about this is that it does a lot of the training and steps for you. It gives you some options to configure at the start. We don't need this to be a time series. It's going to ask us which column to predict on. So one cool thing is we've uploaded this data, so we can preview it from this view. And so here we get this nice little visualization of the type of data that's inside this data set we're using. So you can see loan duration, credit history. We have a lot of values here. And then at the end is this risk value. This is what we want to predict on. Based on all this other info, is it a risk or not a risk to offer this loan to that customer? So we'll go down to this, predict on risk. And here Auto AI has determined that this is a binary classification between no risk and risk, the two strings, where no risk is the positive class. So if we had a different prediction column, is such as like log, like numbered, it might be linear classification or such, but in this case, we have binary. Yeah, so we can, here it's selected the prediction as binary classification, but you can adjust the prediction type. Yeah, regression's the word I was looking for. So the prediction type could be binary, multi-class, regression, or time series. And you can change it. However, it won't let us change it to to regression here because the column type is Boolean. Yes, so but yeah, it is automatic to start. And then again, positive class, so we can tell it that no risk is the positive class. We can tell Auto AI how to optimize. We're letting it use accuracy as the optimization to focus on. And then there's other options here, like which type of algorithms do you want Auto AI to try to use? And then how many algorithms to use. So these are some of the standard default settings, but you have some customization within Auto AI. You can even try to evaluate fairness within this, which I won't show for this demo. And we've gone over, data source. It can do some sort of pre-processing like drop duplicate rows. And then runtime, you can adjust the number of iterations. So that's just a quick overview of sort of the settings to configure an Auto AI experiment. But some of the nice parts of it is you can sort of just grab your data set, pick the prediction column, and just run with it and let it do its work. So we're going to go ahead and start the run. This is a demo data set, so it's relatively small. So we should see it finish training in not too long. It does give a nice little visualization while it's working, which I'll try to talk through some of it. But you'll see that there are steps in the process of Auto AI. The Anand slide sort of showed there's pre-processing, getting the holdout data, then hyperparameter optimization, and feature extraction. And once again, hyperparameter optimization. So we'll let that run. I'll highlight that, it's going to create what they're calling pipelines. So each pipeline is a different way to sort of pre-process the data and train the model. And it's going to eventually, out of all the pipelines, select the one that it thinks is the most accurate. So we'll probably have like maybe a minute before we might see some more interactive or detailed graphics. I saw the questions in chat that we already answered about prediction type, but anyone can feel free to add in chat or speak up if you have questions so far. Yeah, so what is security? There's one question is what is security for PHI data? So a major focus of IBM Cloud is security in general. This current instance I've deployed is on the public cloud. So one server, of course, your environment is isolated, but it is on a server that's shared oftentimes with other different processes. But then there is the option to get a HIPAA certified instance that has its own isolated deployment. And Anand, I don't know if you have anything else to add to that.
Yeah, we have different PHI compliant environment, and if you have that data, there are a set of instructions given to work with any sensitive data because we have certain services which are compliant, and then there are certain environment, and there is a detailed process book to work on such type of data. Yes, but we do offer that.
Great, and we're seeing now it's done the pre-processing. It's starting to show us some details of what it's doing. So here it's selected some pipelines. So each of these pipelines, it's giving a little bit of information. So this pipeline is using an XGB classifier as the algorithm, and all of these appear to have 90% training data, 3 folds, 10% holdout. This one also is XGB classifier. I guess maybe it's going for those to start, and it might try some other algorithms for future pipelines. And each of them has an initial accuracy, so we can see sort of like what they're calling the leaderboard as this comes in, to which pipelines look promising. Yeah, so, and then like Anand said, I think this is a great use case for people learning about the data science pipeline. It gives you an opportunity to sort of see it work end to end and then dive into the details of each part. It's good for the subject matter domain experts who might not be as fluent in data science pipeline processes and may not want to make the entire thing themselves, but they can try with data they're expert in, try it in this sort of service. But then, yeah, it can still even be used by those who are more fluent with data science. And as you saw at the start, you can customize the Auto AI to your needs. So we see it's continuing. This column here, enhancements, is sort of the later part of the process. So hyperparameter optimization, feature extraction, and then once again, optimizing. So we see some of them don't try to do that, but they perform sometimes worse, sometimes better. Yeah, random forest classifier being the next algorithm it's trying. And I can also highlight, so you can see on this top here, it's doing a PCA for 2 of the pipelines. One of the features it made was a principal component analysis of other features. And then here, the univariate feature selection. So these are sort of the type of transformations it might try. Yeah, so Kevin asked, does Watson use its own in-house AutoML library under the hood, or does it take advantage of available AutoML libraries such as H2O, etc.? If it does use others, can that be adjusted? I might defer to Anand if you know the answer off the top of your head.
I don't know how much it can be customized, but it is the our in-house algorithms, and the detail of it, each aspect is given as a research paper for you to read how we are doing this in a programmatically way. But what is exactly used, that I don't have idea right now, but I can find that. But all those research paper listing is there in the Auto AI documentation.
Is it possible to use your own code / algorithms? So I think normally, if you want to do more custom using your own algorithms, that would be appropriate for just using the normal Watson machine learning pipeline yourself.
Yeah. So this is all done with the Watson machine learning and Watson Studio pipeline. So as opposed to using this as it is, as the off-the-shelf, you can use those individual components like Watson machine learning, where you can give your own code and algorithm as the portion. So that same pipeline you can build in parallel in the Watson Studio using our machine learning service. This is an Auto AI where something is already being built as the off-the-shelf.
Yeah, and I think this next question, reinforces that. So yeah, so also, or comment even. So Watson Studio abstracts from Watson machine learning, but Watson machine learning could still be used just for the compute resource. Absolutely, yeah. So I think that's something, if we didn't make clear at the start, we can reiterate here that this is, we're showing almost the most off the shelf of the service with the Auto AI. But if you're familiar with Jupyter Notebook, or running your Python ML libraries like TensorFlow or PyTorch yourself, those can be leveraged directly with Watson machine learning or with Watson Studio. You don't have to go through. This is not the only option to run training.
For example, with Watson machine learning service, if you're directly interacting with it, you can supply your code and say, I want a distributed deep learning, or I want to just do a serverless computing platform underlying, or use this set of GPU nodes. So all of this is possible by going into individual service, but that would be understanding that service. So the demo was a most simple off-the-shelf demo, but yes, those all can be done, and those would be another session if we go in detail about using the machine learning service through the tool Watson Studio abstraction, or directly machine learning tool through API.
Mm-hmm. Yes, I know we're about at time for this talk, but I just want to show, it looks like this has finished. Thanks for all the questions. So this has finished its training. It looks like pipeline 3 has been selected as most accurate. So it can give you some details. The main one I just want to highlight here is I think it's interesting, is the feature summary. So here it's suggesting that the age of the loan, the person requesting the loan is important. PCA of all the features is important, and then the loan amount and whether or not the person applying has other loans already. So at least in like naively thinking about these features do seem like they would be important if you're going to predict on whether or not a loan is high risk, while things like a telephone number aren't as important. So so this is just a nice way to sort of get some information that Auto AI has decided from this training data. Great. So yeah, yeah, that sort of concludes the Auto AI demo. Yeah, like Anand said, there's much more we can do with Watson Studio and Watson Machine Learning, especially if you're already comfortable with programming with TensorFlow and other machine learning libraries. So that could be a follow-up demo we give at a different time. Cool. Yeah, any final questions for this section of the sort of talk before we move on to discussing project ideas with all of you?
Yeah. Yes. So thanks, James. So basically, we demonstrated one of the tool in the Watson Studio capability, Auto AI, but we can demonstrate machine learning in greater detail or any of these other tools in the subsequent focused workshop on machine learning and AI itself. But this was just giving an overall introduction about our platform capability and one simple demo and the off-the-shelf demo, which is easier to visualize. So just to recap what we discussed here, that IBM's AI portfolio is very rich, right from off-the-shelf services to a platform which you can run anywhere, to a more specific component in the platform, the data science platform component, and the machine learning services, different databases. So we offer all this, and all this you can access through the cloud account we have provided, and leverage any of these services, or you can discuss if you have a potential use case and you see which services should be the one which could be helpful. We can help in that. If you need much detail into that, we can get our experts who work and design those services come discuss that with you. So scope is used to collaborate in terms of data science and AI work, and a lot of our collaboration these days are coming around these and the security. So looking forward to listening to all the ideas which you have, or seeing that you find a use case to use it either in research or teaching.
Great, thank you so much. It's a phenomenal presentation, and now we are going to open floor to our researchers with questions. Well, while everybody putting their ideas together, I have a question. We have two large-scale medical projects. One in use of the AI for health disparity. So where we're building communities and basically would like to build tools to democratize the access to the healthcare facility for basically population that doesn't have an access, or for whatever reason not aware what kind of information is available, streamline the communication. So we're building community. It's a large $100 million award from NIH. We are part of the infrastructure core, where we are poised to deliver tools around this area. So I guess the broader question is to Andy and the group, whether you guys are interested in being one of the participants in these projects and whether your group would be interested in supporting this activity at the national scale.
Well, I mean, we can discuss it further. We're generally interested. We're not looking for any funding, but it's a huge allocation in terms of cloud support, and/or it involves more than universities. Then, we'll for non-universities that would probably be a discussion we'd have to have with our sales team. But otherwise, we're ready, willing, and able to work with you and explore what would be possible. As hopefully would be evident, the more universities we can touch, the more universities we can get engaged with. We'll,
Right. There are about 26 universities involved: Harvard, Stanford, UCSF, Hopkins, Duke, and what is more interesting, it's led by the National Consortium of Historically Black Universities and MSIs. So we have large contingency of the university community that is actually taking advantage of this methodology. So we're actually even creating like a network of Florida universities that have these issues, because it's sort of in the realm of training the trainees, because not every university have the same capacity. So we want to, to develop the tools and then create pipelines, but also do training around them. And go from there. We're also creating a lot of workshops, and we're creating national forums, educational forums that would educate about the problems. So we'll be doing a lot of keynote speakers, building communities, looking at rural areas where perhaps telemedicine would be one of the interesting applications for this type of infrastructures. So that's one project. The other project we want to discuss with you, and we can also take it offline, is we are finalizing a large-scale research agreement with FDA, where we'll be working on the concept of software as a device, as things kind of changing, and we are using AI to diagnose and come up with the better treatment regimens or come up with so-called digital therapeutics. AI becomes a very prominent, or machine learning, very prominent way of delivering this tool. So FDA is interested in creating a testbed as a service with us, University of Miami, and a few other universities that we are adding to the pool. Try to understand unbiased AI, trying to make sure that the testing of the proposed solutions can go to the market without any problems, that we are actually capturing all possible situations, so explainable AI and biased AI, and then how this testbed can lead to the methodological development of assessments for the regulatory science, right? So it can power regulatory science. So first you come up with novelty, then you evaluate the novelty, but as you go through the evaluation and improvement, how you can use it to understand the way things needs to be evaluated. So that's more on the research side, but there, of course, if you guys have an interest, you can help us tremendously as well. So that's another project.
So the short answer, the simple answer is yes, we're interested. So I would suggest we set up follow-up discussions. A lot of the universities you mentioned, we actually are already working with, and many we're providing free cloud. So yeah, I mean, expanding those relationships is something that we'd be extremely interested in pursuing.
Great. And okay, that's fantastic. So I'll make sure get on your calendar, and that sounds wonderful.
These testbeds can use these off-the-shelf open source IBM container platform. So for example, all these trust and transparency and explainability tool can be used from the open source community on the Red Hat OpenShift as a platform, and can help you do that testbed as a service where people experiment with it very easily. And we would be happy to help in setting up that.
This would be great. Now, the other question I have, whether you guys did it already or have an experience in building analytics as a platform. Or more interestingly, I'm personally excited about building the concept or developing the concept, building analytics of analytics, sort of in the realm, I guess, of genetic algorithms, where you would look at a bunch of available analytic solutions to specific problems and try to figure out which one would fit the best and how you would even classify the problem space in a way that you can identify the most appropriate solution. So do you have products like that, or at least can we do some joint kind of studies in this area? Because as the field matures, things
that is similar to this auto AI concept, right? Which one fits best with the data, sort of thing. So yeah, definitely interested in looking into those use cases.
Right. Look at the use cases. I think, again, we have a big medical school, medical system, so applications are medical, but there is also obviously climate change and cyber. I was just on the phone before we started our workshop with the head of university relations for NSA, and there is a lot of interest there in this area from the kind of cyber analytics perspective, right? So it's not even cybersecurity, it's cyber analytics, right? So they're looking at all kind of evaluations, like they have all kind of people analyzing the data for different purposes, public safety, and even health is a matter of national security, right? And food, delivery of food, food disparity, public safety, all these things is kind of interrelated. But if you take it kind of one notch down and look at the platform that powers all of this, it's horizontal, right? So taking all these tools, putting them kind of in one mix and selecting them properly and doing it automatically, it seems to be still
absolutely. So what I think you want is a pluggable framework, right? Where all these tools can fit in. Yes, absolutely. Very much interested in pluggable things. Jeb was here, I thought, a while back. I think he had to leave probably. So he's an expert in that area, security and.
Right. No, I'm working closely with Jeb. Yeah, we have a project actually with Jeb with Intel on confidential compute. Yeah, so we have every week we have a meeting with him. So yeah, so I'll bring it up with Jeb. But I think it's not just cybersecurity. I agree with you. This cybersecurity problem, but I think if we dream big, it seems to me it's more of a platform solution, right?
So in short, whatever I build, I try to make it pluggable, right? Yes. So we have to find out a common platform where you plug in different things, and that's the easiest way to expand, right? So you can only work on certain things at certain periods of time, and then you plug in and go more in different areas.
Right. So the question is, so shall I start with Andy? Maybe we can create kind of a la carte menu, and then maybe we can create groups. What would be the best way to organize our research moving forward?
Yeah, that sounds reasonable. And again, as we said, let's have some follow-up calls with the team to discuss the details. So
perfect. Okay, do we have more questions, guys, from the group?
Did we answer all the questions in the chat?
I have a couple projects that we're looking into using this kind of technology. One is a current project. So my name is Roberto Benzo. I'm a postdoctoral fellow here at the University of Miami. And I work with Tracy Crane and Frank Benito, who are my mentors here, who are the co-leaders of the cancer control program. So one of the initiatives that's happening here is called My Wellness Check, which is the idea of using the electronic health record along with integrated symptom screening and a referral system to be able to identify unmet needs in individuals who may have increased symptomology, so that we can intervene and refer them to the appropriate cancer support services. For example, there might be dietary needs, and they'll be transfer to nutrition, or it could be psychosocial, psychiatric, a variety of things, even physical function leading to like prehabilitation for physical medicine rehabilitation. So right now we've been analyzing some of the data, something that we're working on publishing at the moment, where we see two different groups. We compared basically those that respond to these assessments. And let me actually take a step back here. So this My Wellness Check, again, it was developed to assess physical and psychological symptoms in oncology patients. So once they're diagnosed with a cancer, they automatically get like a message sent to their MyChart. The assessment asks them to, well, the message asks them to please respond to the survey, and that's how we find out where they're at and how they're doing, more than the oncology team and the medical team, given the, you know, the burden and the heavy schedule. So right now, we started with the oncology clinic, we've expanded to different clinics, and we've recently like analyzed some of the data, and some of the preliminary findings are showing that people that actually respond to this, you know, not everybody gets their need addressed necessarily or solves the problem. But the people that respond, it seems like there's a significant reduction in hospitalizations as well as like ER visits. And so we're trying to understand the data a little bit more, but given that this is kind of a new initiative, the architecture is still kind of being built, there's sometimes not a referral button or things that doesn't allow us to track which services these patients are going to, and limiting us in terms of finding out how much they improve in a particular symptom, or the symptom that passed the threshold that engaged this whole thing. And so one of the things we're interested in doing is using perhaps NLP or natural language processing to go through their notes, the doctor's notes, to figure out what services they actually been to. And also there's a lot of heterogeneity in terms of the conditions, right? So somebody may be different age, different cancer, different stage, different medical comorbidities, as long as different treatments, not only like the type of chemotherapy, but how many chemotherapy sessions you can endure. So it's just a very complex situation. And so we're also interested in perhaps using some of these approaches to be able to gauge what are the things that predict perhaps improvement, or on the other side, a deterioration of their medical condition. So that's the first project that I wanted to
So Robert, let's pause a little bit on that first project. So yes, so you're analyzing data. One part of the problem is to also collect the data, right? So the Nectar project that we mentioned was kind of designed that way. How can we collect data from patient more efficiently who sign up, right? So obviously there's some privacy concerns there as well, right? So, but if they do sign up, that was analyzing their mood and behavior. This would analyze some other aspects, right? So rather than just focusing on serotonin and dopamine, we can focus on other things too, right? But the idea was, can we indirectly collect this kind of data that can give some indication, right? Like blinking of eyes is related to dopamine, for instance. With Apple Watches or other wearables these days, you can collect a lot of information. Sweat has a lot of information in it, right? So this kind of data collection is also needed. And then we obviously have the data crunching and the analysis part of it.
I completely agree with you. We have kind of, I failed to mention this, but aside from getting like the MyChart, we have backups, because anybody with a cancer diagnosis will get this kind of pop up in their thing. So if they don't answer it, so it happens every 30 days around a medical appointment. So if they don't answer, then when they come into the clinic, there's like various, so either a registration or where they see the nurse or where they see somebody else, there's opportunities where they can fill that out on paper and things like that, so that we can kind of avoid missing data. But still, that's something that we're also very interested in, and is figuring out what drives engagement. You know, what drives them actually completing, because sometimes not everybody completes all the measures that are in there.
Exactly, and there's other implications to that, insurance and other things, like the prosthetic project, right? So, and so the RIC, Rehabilitation Institute of Chicago, is working with something back, which is called the Ability Center now, part of Northwestern. So they they are the best in creating some of the prosthetics and training folks in prosthetics, working with Johns Hopkins. The problem is they don't have any data when the patient takes a prosthetic home, right? So how do you retrain that? How do you so the prosthetics are built with AI. I mean, the most sophisticated prosthetics we're talking about, right? And they've open sourced many of that under MI, University of Michigan, right? So there's open prosthetic. Plus, there's more research going on with Levi Hardgrove and stuff. So, so yeah, so data is always important, right? How he's moving, how much he's using the prosthetic and things like that. So in your case, the cancer situation, right? There's other parameters that we can probably monitor and things, and everything comes with privacy, right? So they have to agree to each and every thing, then we can monitor that.
Absolutely, absolutely.
On top of that, for example, some of the HIPAA compliant services you can use in this project. For example, our service on clinical data annotation. So you were talking about there is a lot of textual data and you have to extract different information like they are not feeling well or other things. So you can make the model. We provide the tool. Using that, you can make the annotate all those data and get all those insight into our NLP engine, and then use that to orchestrate and create a dialogue what is needed for that patient. So yes, there are various components, and some tool of services can be used directly off the shelf with some training by you or your group.
I should have mentioned at the beginning, I'm a behavioral scientist. I have taken classes in machine learning and things. I'm in a deep learning and AI class, and have like we're actually using the Watson or the IBM dashboard right now. But to be honest, I'm not an expert in this stuff, and that's why I'm here, is just to figure out who I need to talk to get help and to better understand. And I'm just trying to understand the limits, so that way I can speak to people like you guys that are the brains behind this these kind of modeling. So that being said, yeah, I would love to talk to you guys more about that. And then very similar to that first project, and I don't want to take up the whole time, but just 5 more minutes if that's okay. So the second project is also very aligned with this. It's where we're trying to, we know that the lifestyle behaviors are directly related to, in the cancer population, lifestyle behaviors are directly related to like how well they uphold treatment, their symptomology, reductions of fatigue. So not only symptoms coming from the treatment, but also from the disease. And so there are recommendations by ACSM and the American Cancer Society specific as to physical activity, diet, and other things has to do for cancer prevention. And often those are very much aligned with also for cancer survivors, which is anybody that's been diagnosed with cancer is automatically a survivor is the definition. And so my personal interest is a lot of lifestyle research and the use of technology to understand that. The way I was trained was always like surveys, and maybe I've used a lot of accelerometers. But I'm really interested in using passive sensing through either smartphones or wearables to get a better picture of a digital phenotype of somebody that's moving around. How much can we learn from somebody just by with permission of using their data?
It's amazing how much we can learn, and the surveys are not always very accurate, because you're influenced because. When I'm filling up a survey, I'm a little bit influenced and paying more attention than what I'm actually doing, and probably I don't want to expose some of my bad behaviors either, right? So
right,
yeah.
I mean, you're totally right. I mean, it's there's white coat syndrome, and there's recall bias. There's so many reasons as to we may not get the full picture. I mean, there's like a big study by Trina and 2009, where they first looked, they included accelerometers in the NHANES data, which is the national survey for where we get this information. And they saw that 45% of people reported that they met the physical activity guidelines for Americans. But then the accelerometer said only 5%. So right there, it tells you, hey, there's a bit of a discrepancy. However, there is
I can
always
tell
a
you what
place.
people do with the what is that the counting steps. What's it called?
Yeah, like a wearable or a step counter or whatever.
Yeah. So it started with Fitbit, right? And I know what people do with those things to get to the 10,000 steps, right?
Right. I mean, so creativity is endless for humans. There's no doubt about it. And so that being said, a project that I've been working on developing and I have support here, and I'm putting a K in for as well, is to make use of this data. And I guess I wanted to say before then, but although I love digital data and not asking to burden people that are already burdened by disease and general life and stress, surveys sometimes do have a place. Like we haven't yet figured out how to measure diet, right? I mean, right now, diet, the gold standard is a form, it's a 24-hour recall. And just because even though there are cameras and they're using microphones and then AI and deep learning to figure out how much you're eating, at the end of the day, for now, the best way is a survey, unfortunately. But moving forward is my project is revolved around using this data, using wearable data and digital data to be able to understand how much patients are adhering to these recommendations. And then the development of two dashboards, one for the EHR, so information integrated into the EHR, and a dashboard for providers that allows them to see where patients are in terms of adherence and how they want. And so we're going to have a whole qualitative phase where we plan on figuring out what do you want to see, how do you want to see it, when do you want to see it, and so forth. And the other dashboard for patients with the same process, user iterative design to figure out what do you want to see, what are you going to engage with. It doesn't matter if I make the most beautiful thing, if you don't use it, it's worthless.
So the best way is self-correction rather than telling someone what to do, right? So that was the approach with the Nectar as well, right? So people are depressed or whatever, so there you can measure that through dopamine or whatever. At the end of the day, if you tell someone, okay, don't do this and do that, and you'll feel much better, they're likely going to do it a couple of days and not follow the routine, right? Because it's just human nature. So the reason they're depressed is probably there's a reason behind it and all that, right? So it's difficult. However, if they can self-monitor, like, so you don't send the graph to their doctor, you just show them that just by doing certain things, their index is going up, they're more likely to change their behavior.
We're on the same page here. Absolutely, in that sense. And so what's the problem now is you come in for your 20-minute visit about your cancer and hey, are you moving? Oh, yeah. Are you eating well? Yeah. Okay. Make sure to eat well. Okay. Bye. That's it. And so we don't really know the whole story. And even if we give them an accelerometer, I mean, we know now, depending on the accelerometer, how many days you have to until you have a more reliable measure and things like that. But the idea is to not only have the beauty of a non-judgment zone where they can actually see how their activity, where they're at, where they're supposed to be, and also maybe down the line, the idea is to do risk stratification to figure out, hey, it seems like your lack of activity is probably causing the drive and fatigue. Just how we saw that age was a major predictor in that demo. But so the idea is to not only create awareness on both ends, but to facilitate communication, empower patients to do something by presenting the information in an appropriate way. And that's kind of, that's the project. I can keep going forever, but I don't want to take up everybody's time. And, but I would love to talk to you guys more. And that's all I have. Thanks, guys, for a good talk today.
Yeah, absolutely.
Very good. There are definitely a set of tools and services we can think of which can help in the project. So yes, let's follow up with another detailed call on the project.
Thank you.
That sounds good. Any more questions, guys, from UM team? Well, it looks like we covered a lot of material. So, Andy and Anand and the group, what is the next step?
I think, well, we've had lots of follow-up discussion here and potential projects that we want to further pursue. So I would suggest, just to make sure that we don't forget about any, for those who have well, even for those that haven't brought up any potential collaborations, feel free to send us an email. I guess all of our emails should be on the announcement for this event, and also I think I put it in the chat. The other guys can put theirs in the chat. So reach out to us, and then we'll set up follow-up meetings. And again, even if you haven't said anything here, if you think of something or decide you would like to take one of the projects that you're working on and collaborate with us, please do so.
That's fantastic. I would like to thank our colleagues from IBM, and this is one of hopefully a number of different workshops, and we'll hopefully have the next one in person as things starting to open up, and looking forward to a very long-term, or continue, I should say, a very long-term and productive collaboration. This was phenomenal. Thank you, guys.
Thank you so much.
Thank you, Yelena, so much for setting this up, and everybody else on that side. Well, those who participated, as well as those who helped you, get this up and running. So,
thank you, guys. Great weekend. Appreciate it. Talk soon. All the best.
All right.
Bye-bye.